Hello everyone, this is Alice, and welcome to Different Views of Functions Part 2. If you haven't watched the first part, I highly recommend that you do so, as it starts us to think about this particular problem. The link to this video can be found in the comments below. So in our last video we showed how graphs, equations, and charts can all be used to represent the same function. In this video I will show how to extract information such as the slope or the x or y-intercept from the function regardless of what form it's in. So let's first look at the left side of our screen here at our graph, and let's consider slope. So in algebra we learned that the slope is the change in x, or the change in y, sorry. Change in y divided by the change in x. So what does this mean visually? So basically that means for some distance that we go up, how much do we go over? So in this case we went up 2, and we went over 1. So our change in y, and remember this is our y-axis, this is our x-axis. So our change in y was 2, we went up 2. And when we went up 2, we went over 1. And remember that our line is our reference here. So starting on a point on the line, how much do we go up and over to get back to the line? And so we see that in our x direction we changed by 1. So the slope is just 2. And notice that it didn't actually matter that we only went over 1. We could have picked a different distance. Like we could have went 4 and over 2. And our equation still works. So then our change in y is 4. Our change in x is 2. 4 divided by 2 is still 2. So we don't always have to just go over 1 if another distance looks more convenient to like grab the numbers from. Yeah, it's just whatever, starting at a point, going up and over to another point, what's our change in y divided by our change in x. So that's how we'd kind of try to pull the slope if we just had a graph of it. So what about in an equation? How is slope represented in an equation? And you may have already noticed that we have a 2 right here, and our intuitions would actually be correct in this case. This is our slope. So the first thing I want to introduce, and maybe you've seen this before, is the idea, or the idea of slope-intercept form of an equation. And what slope-intercept form is, it's an equation rewritten to look like this. So what do I mean by that? So it's an equation where your numbers and variables are written in this form, where m and b are just some numbers and x and y are your variables. Slope-intercept form is a useful form of the equation, especially when we're working with lines and trying to get information out of them, because our m tells us our slope, and our b tells us our y-intercept, which we'll talk more about later. And it should be a little bit intuitive why this number is our slope, because thinking about what our slope is, it's how much we go up every time, how much we go up and how much we go over. So we found out that our slope was 2, so every time we go over 1 in x, our y goes up by 2. So, and there's also this plus 1. So yeah, let's just think about this. So let's plug in our point. Let's plug in our point x equals 0 into our equation. And we find that we have y equals 2 times 0 plus 1. So we have y equals 1. So we know the point 0, 1 exists on our graph. And it does right here. So now let's go 1 over. So let's do x equals 1. Find out that y equals 3. So we know the point 1, 3 is on our graph. So what we noticed is every time we went over 1, we incremented our x by 1, we went up 2, so we went from 1 to 3. So basically this 1 told us, okay, so we need to start on our y-axis, we need to start at 1, and then every time we go over 1, we go up 2, and that's what this part is telling us. So now, how do we see slope in our chart? So there is no direct thing. We can't like see it like we see it on our graph, and it's not just some number in our equation once we put it in a certain form. But we are able to look at the pattern of what's happening in this chart and figure out the slope that way. So what we want to do to find the slope when given a chart of numbers is look at the difference between each of our numbers. So the difference between 2 and negative 1 is 1. The difference between negative 1 and 0 is 1. The difference between 0 and 1 is 1. So every time we go up by 1, let's see what happens with our y. Or go over by 1, I'm sorry. So to go from negative 3 to negative 1, that's plus 2. This is also plus 2. So notice the pattern here. Every time we go up by 1 over here, we go up by plus 2 here. And remember, our slope is just our change in y divided by our change in x. So we can just take our change in y, so our plus 2, and divide it by our change in x, which is just 1, and we find that our slope is 2. So no matter what version of a function you're given, you should be able to sort of grab the slope out of it using these different methods. So now let's see how we can extract a y-intercept. In our graph, the y-intercept is just the place where the line, our purple line here, crosses our y-axis. So we've actually already found it. It's this point right here. There's 0, 1. So it's really easy to find intercepts on our graph. It's just the place where the line crosses our y-axis, or in the case of an x-intercept, is where it crosses our x-axis. And we'll talk more about that later. So yeah, our y-intercept is 0, 1. And something interesting to note is, think about all of the points on the y-axis. So this point here is like 0, 5. This point here is 0, negative 2. So our y-intercept will always be on our y-axis because by definition our y-intercept is where our y-axis and our line intersect. So our y-intercept will always be on our y-axis. So notice that all of these points have a x value of 0. And that makes sense. Since we have to be on our y-axis, we don't go to the left or the right of the y-axis. So our x-coordinate will always be 0. And we're going to use this fact to help us find our y-intercept in our function, or in our equation form. And so we talked earlier that if our equation is in slope-intercept form, that this number right here is just our y-intercept. And that's true. But I'm going to show you a method that works no matter what form your equation is in. So, and we're going to use this fact here that we know that our x always has to be 0. So all we're going to do is we're going to just sub in 0 for x and solve our equation. 2 times 0 is 0 plus 1, and y is 1. So by putting in x into our equation, we can see that y equals 1. And since only one point on this line will have an x-coordinate of 0, we can feel certain that the 0, 1 is our y-intercept. So how do we find it on our chart? It's basically by using the same technique. So we know that the 0 right here So we can actually just see our y-intercept right here, and we're using the same idea, which is we know that the x-coordinate of our y-intercept has to be 0, and we can just see it right on our graph that it's just written out for us. So let's pretend that we weren't told explicitly that 0, 1, the 0, 1 wasn't a point on our line. So let's pretend like this information wasn't here, and let's pretend like this was our graph instead. -3, 5, -1, 1, 3. So these are also points that are on our line, but it's just a different set of points than we have here. So let's pretend that we were given this instead. So in this case, we weren't given the point where the x-coordinate was 0. So, but that doesn't mean we still can't figure out what the the y-intercept is, because we can extrapolate what it is from the information here. And we're going to use the same technique we used with slope, where we're going to kind of look at the pattern of what's happening here. So the difference between -3 and 1 is 2. The difference between -1 and 1 is 2. The difference between 5 and 1 is 4. The difference between 1 and 3 is 4. So we see that our slope, unsurprisingly, is our change in y, 4 over 2. It's still 2. Our function hasn't changed. But what we want to consider is that we want to use the fact that we can use different fractions to represent the same number. So 4/2 is the same as 2/1, is the same as 6/3. All these represent the same thing. They all represent the slope 2. So maybe what we want to do, instead of incrementing by 2 and then 4, we want to increment by 2 and 1. And so we're going to look at this -1 point here, and let's just pull it down here. Pull this guy down here. And instead of incrementing by +2 on our x and +4 on our y, we're going to increment by +1 and +2. So -1 plus 1 is 0. 1 plus 2 is, this is supposed to be -1, 2, I'm sorry. -1 plus 2 is +1. And we find that we do end up being able to extrapolate that we have this point 0, 1 also on our line. And from what we showed earlier, we know that this is our y-intercept. And really, we do basically the same thing for x-intercepts. So we have our x-intercept here, and it looks like this is about 1/2, 0. And this actually kind of shows us the limitation of trying to just pull our x-intercept off a graph. Like, this isn't directly at one of our marks here. And so where it looks like 1/2, we often in math, it's not, if you're given a picture, you shouldn't explicitly trust everything in that picture. Like, if it like, oh, it sort of looks like it's, if you feel like you're saying something like, oh, this sort of looks like it's 1/2, you should stop yourself and ask if there's a way you can get a precise answer. And sometimes there's not, sometimes maybe that's just what your teacher wants you to do. But if there is a more precise way to get your answer, you should definitely go for that. So say we were given this line and this function. There is a precise way that we could find our x-intercept. And we're going to use the same observation that we used for our y-intercept. So note that since our x-intercept is our x-axis, the place where our x-axis and our line intersect, that the y-coordinate always has to be 0. For any point on our x-axis, our y-coordinate is 0. Because we don't leave the line, we don't go up or down from the x-axis, we're always going to be on this line. Our y-coordinate will always be 0. So we're just going to use this fact like we used it before. And I'll go ahead and switch to yellow for this. So for our x-intercepts. So I'm going to scroll down a little bit. So to find our x-intercept, we just need to plug in y this time. So our 0 for y, and we're going to solve for x. Subtract 1 from each side. Negative 1 equals 2x. And then, we're going to divide 2 on each side. And we're going to get x equals negative 1/2. So our observations work for x over here. This 1/2, our x-intercept is 1/2, 0. And again, if we just had a chart, we could do the same thing to solve for our x-intercept. So for our x-intercept, we're looking for the point where our y-coordinate is 0. And let's go ahead and look and see if we already got it. And it looks like we don't. We have no y-coordinate that equals 0. But it looks like that there should be that, we're kind of missing a point between here and here. Like we talked about in our first video, lines actually have an infinite number of points on them. So we can't always write every point. But it looks like there's a point missing between here and here that might satisfy what we need for our x-intercept. So let's sort of think about that. So we want to go from negative 1 to 1. So we need this number to change by 1. So what do we have to do to our change in x to accommodate that? So we can kind of think of our slope in a different way. We need our y to change by 1. So what can we divide 1 by to get a slope of 2? What can we divide 1 by to get a slope of 2? Since we want to change our y by 1 to get this 0, we need to figure out what our x needs to change by so it still equals 2. And if you kind of can recall back to how division with fractions work, we can remember, and this is just kind of an aside, that when we divide, let's use a different number, 3 divided by, let's say, 2/5. So if we have kind of like a fraction, we're dividing a number by a fraction, this is equivalent to 3 times the reciprocal of this fraction. And if you remember what a reciprocal is, it's just when we take the fraction and we flip it upside down. So this is the same as 15/2. That's just sort of an aside to just remember how dividing by fractions works. So if we think about this rule, then for our slope, if we do 1 divided by 1/2, this is the same as 1 times 2 over 1, which is just 2. So what that tells us is every time we change by 1 in our y direction, we should change by 1/2 over here. Actually, I haven't been saying this is negative. This should be negative. So we have negative 1 plus 1, which is 0. And we have negative 1 plus 1/2, which is negative 1/2. And we do find, again, that our x-intercept is negative 1/2, 0. So if you have any questions or comments about this video, post them below. If you have a different question you'd like to see answered, please email me at asklf0@gmail.com. Thank you for watching, and I hope to see you in my next video.